Continuing in Chapter 9, we're going to be adding and subtracting rational expressions today. Rational expressions are simply fractions, so when we learned to add and subtract fractions, we realized that we needed a common denominator to do that. So that we're going to do the same idea here, and you see some steps here. We're going to factor the denominators, and we're going to use the factors to help us find the common denominator. And we actually want the least common denominator, and then when we do it, we would do our adding and subtracting. I have this simple 1 over here. I have this simple adding fractions here just to show you something that we want the least common denominator. I want to just do this simple one here to show that it's better to do the least common denominator rather than just a denominator. So when we add these fractions, we will want to have a common denominator. Well, we may think or have learned we can just do 4 times 6 is 24, and that works, but that is not the least common denominator. And it's pretty important with the ones that we're going to be working on today, the rational expressions, that we use the least common denominator, basically because it's going to make it a lot simpler for us. So here, instead of doing 4 times 6 is 24 and using that as our common denominator, we know that 4 and 6 both go into 12. And so here we can multiply this side by a 3 over 3 to get 12, which would give us 9/12. And on the right side, we can multiply this by 2 over 2, and that would give us 2/12. And then we could add those to get 11/12. And so we're going to be doing the same idea when we add or subtract rational expressions. Coming to this first example, we see that these already have a common denominator. So we have a common denominator of x minus 1. So we can combine these. Now we have to be careful because we're subtracting. So when we're subtracting, we need to make sure we're adding the opposite. So really this is 2x plus 5 minus 6x plus 3. Because when we subtracted, we need to make both of these negative, both the 6x and the negative 3. The negative 3 changes to a positive 3. Now we can just look at our numerator and add like terms. Our denominator is still an x minus 1. In the numerator, we have a 2x minus a 6x, which gives us negative 4x. And then a 5 plus 3 is 8. Remember, we learned to simplify these, so I want to make sure this is simplified, so I'm going to factor this to see if I can reduce anything. I like my first term to be positive, so I'm going to factor out a negative 4. That leaves me with an x minus 2. And then in the denominator, I have an x minus 1. Nothing simplifies there, so that is our answer. Looking at our next example here, we see that our denominators are close to being alike, but they're actually opposites. I like the descending order better. I like the x minus 3 better. So if the denominators are opposites, what we can do is we can multiply by negative 1 over negative 1 for the second fraction, the one that is not in descending order. When we do that, we see that we still have our 5x plus 4 over x minus 3 plus, and if we distribute these negative 1's in here, we'll get a negative 3x plus 1 and a negative 3 plus x. Well, this negative 3 plus x is really the same as x minus 3. And now we have common denominators. So we do that, again, when we have denominators that are opposite of each other. Now that we have a common denominator, we can write this with a common denominator, and we can combine these. So 5x minus 3x is 2x, and a 4 plus 1 is 5. We want to simplify if possible. We have a 2x plus 5. That doesn't factor it all over an x minus 3, so that is our answer. Let's take a look at this next one here. This is a case where we are going to want to factor the denominator. The numerators don't need to be factored. But notice here we're finally going to use this first step because our denominators are not the same. So we're going to factor this. So we have a 5x over factoring, we would get x plus 3 times x minus 2. Over here we have x plus 7 over x minus 2 times another x minus 2. So now we're looking for the least common denominator. Our first denominator has an x plus 3 and an x minus 2. Our second denominator has an x minus 2 and an x minus 2. So what we're going to do here is we want the least common denominator. So since this has two x minus 2's, this first denominator also needs two of them. So the first denominator we're going to multiply by another x minus 2 over x minus 2. We're going to multiply the whole fraction by that. That way we'll have a denominator of x minus 2 times x plus 3 times x minus 2. Our second fraction, in order to have a common denominator, this needs the x plus 3. And so we multiply top and bottom by x plus 3. Now we notice that each denominator is, we have x minus 2 times x minus 2 times x plus 3. I'm not going to multiply those out now because I could possibly simplify later. In the numerator for this first one, we would have, when we distribute here, 5x squared minus 10x. And I want to add, and we're going to have to distribute here. So multiplying these out, we get x squared plus 3x plus 7x plus 21. Now combining those like terms, we still have our common denominator. X minus 2 times x minus 2 times x plus 3. And in the numerator, we can add like terms. So we have a 5x squared plus x squared is 6x squared. Negative 10x plus 3x plus 7x, that is just 0. And then we have plus 21. And what I've done before, I make sure I factor this just to see if we can simplify anything. In the numerator, we could factor out a 3. And we're left with 2x squared plus 7, which will not end up reducing with any of the denominators. So instead of writing x minus 2 times x minus 2, I'm going to write x minus 2 squared times x plus 3, which again doesn't simplify, so that's our answer for that one. Here we're going to subtract. So again, to subtract, we have to have a common denominator. So right now we have a 4x plus 2 over x plus 6 and x plus 5. And we want to subtract x minus 1, and this factors to x plus 6 times x minus 4. So we notice in this one, to get a common denominator, both of them already have an x plus 6. The first one has an x plus 5, but we need an x minus 4. So we're going to multiply by 1, and the special form of 1 is x minus 4 over x minus 4. The second fraction needs an x plus 5 to have a common denominator. So we're going to multiply numerator and denominator by x plus 5. Now that we've done that, we have a common denominator. Our common denominator is x minus 4 times x plus 6 times x plus 5. And doing our work here with the numerator, we're going to have to multiply each of these binomials. So we have a 4x squared plus 2x minus 16x minus 8. I'm going to be careful here. I'm subtracting what I get over here. So I'm going to put parentheses here because I need to subtract this whole thing when I multiply this out. So I have an x squared plus 5x minus x, that's the minus x, and then minus 5. And again, I'm subtracting here. So instead of subtracting, I'm going to change this to adding the opposite. So I'm going to add, I'm going to do the opposite of each of these. So that will become negative, negative, and these two last ones become positive. Now that I have that set up correctly, I can now combine like terms. 4x squared minus x squared is 3x squared. Then we have a 2x minus 16x minus 5x plus x. We get negative 18x. And then we notice we have a negative 8 and a positive 5. That gives us a minus 3. Our denominator is still this x minus 4, x plus 6, and x plus 5. I'm going to factor the numerator in case we can cancel anything. Factoring out a 3 will give us an x squared minus 6x minus 1 over x minus 4 times x plus 6 times x plus 5. That numerator does not factor any further, and so that's going to be our answer. Our last example here is another one of these compound fractions. This one's a little different because the numerator is not simplified and because the denominator is not simplified. So what we need to do with this one is, before we can do our division, is we need to add what's in the numerator and then subtract what's in the denominator. In order to do that, we have to have common denominators. So for the numerator, our common denominator is an x. So we're going to need to multiply our 5 times x by x over x. And then in the denominator, we have a denominator x squared. So this 25 needs an x squared in the denominator. So we're going to multiply by x squared over x squared. That leaves us with a 5x plus 1 over our common denominator of x in the numerator. In the denominator, we have 25x squared minus 1 over x squared. And now we can think division. We have this fraction, which means division. We can think we have our numerator 5x plus 1 over x, and division is the same as multiplying by the reciprocal. So this will give us x squared over 25x squared minus 1. And so what we want to do is we want to see if we can simplify or factor any of these. The first fraction we can't simplify at all, so we're going to leave that the same. The second fraction, we can't do anything with the x squared, but this denominator should kind of stick out to us. This is a difference of squares. So in order to factor a difference of squares, we're going to take the square root of this first part, which is 5x, and we're going to think the square root of 1 is just 1. So this is going to be 5x plus 1 times 5x minus 1. So make sure you check carefully, think through it if you can factor it. That one may not look factorable, but remember difference of squares. Now that we've done that, we can simplify here, because this 5x plus 1 cancels with this 5x plus 1. That just reduces to 1. And then x squared over x, we can think, well, you subtract the exponents. So we're left with x over 5x minus 1.